Hello, welcome to this tutorial. In this video, I'll be demonstrating how to optimize using the Lagrangian method. Okay. Now, when we say constraint optimization, we're basically looking at where we are constrained to say the production levels for product X and Y is restricted to 42 units, but our total cost function is that one. So we are trying to find out the minimum cost that we can, the number of units that we are going to produce for product X and Y, which will equal to 40, while it's reducing or minimizing the total cost. That's what we are trying to do here. So we are trying to reduce the total cost, having to produce two products X and Y respectively. So what we are going to do, if we are using Lagrangian method, there are steps to be followed. The first step, which is step 1, is basically to multiply the constraint function, which is this one. This is our objective function. The objective function is what we're trying to achieve. What are we trying to achieve? We are trying to minimize the total cost, okay? Having given the condition that X and Y should equal to 40. So our constraint is should equal to 42. So our constraint is X plus Y equal to 42. All right. So this constraint, we're going to multiply the constraint by lambda, which is that, and then add the constraint function to objective, what we are trying to achieve. So let's process the first step. So X plus Y minus 42. What I've done is I've just brought the 42 here so that I can multiply everything by lambda. And then I have a lambda multiplied by X will be X lambda plus Y multiplied by lambda. It will be Y lambda. And then lambda multiplied by 42 will be minus 42 lambda. Okay? And then this whole function, we are going to add it to the constraint function. So right now this becomes the Lagrangian function. When we add the constraint function, which has been multiplied by lambda, to the objective function, it becomes the Lagrangian function. Plus this, the order of this thing which I've multiplied by the lambda. So I've just written the objective function here, and then plus that, X lambda, Y lambda, minus 42 lambda. Okay, there we have. Then we are going to derivate each function. The second step, step 2, we are going to derivate each function as with regard to each variable. So we have got how many variables? We've got the X variable, we've got the Y variable, and then we've got the lambda variable. So we are going to derivate these as with respect to each variable, and then we call this as the first order condition. First order condition, which is fork. Okay? First order condition, we're just derivating, so don't be intimidated when you hear the word first order condition. Alright, so we are derivating the Lagrangian function with respect to X. So how we derivate, we multiply this, the power multiplied by the number in front, 2 multiplied by that will give me 16x, and then when we are derivating, we say this power minus 1. So it's 2 minus 1. 2 minus 1 will give me 1. So this is as good as 16x raised to the power 1. Now we don't try to raise to the power 1, we just leave it the way it is, like that. Okay? And then here I'm derivating with respect to x again. So what will happen here? What will basically happen here is that x is raised to the power 1, and then there is a negative 1 in front here. So negative 1 multiplied by x will be negative 1. And then 1 here, which is the power, 1 minus 1 will be 0. Anything raised to the power 0, anything, and I mean to say anything, either it can be 1,000, 1 billion, as long as it's raised to the power 0, it is equal to 1. So here, x is raised to the power 1, but after derivating, we said x multiplied by negative 1, which is in front there, is negative 1. We said negative 1 multiplied by 1, which is the power there, is negative 1. Okay? And then the power itself, 1 minus 1 is 0. So if the power is raised to the power 0, anything raised to the power 0 will be 1. So the x now has become 1. Okay? And then we are remaining with y here. So we have a negative 1 multiplied by 1 multiplied by y, which will be just negative y. So in simple terms, since x is raised to the power 1, and at some point x will be raised to the power 0 after derivating, anything raised to the power 0 is equal to 1, it means that it will collapse. Alright, so I've derivated here, and then here, what is happening? There is no x, I'll skip it. Here there is x, and remember x is raised to the power 1. As long as it is raised to the power 1, it means it will collapse, meaning I'll just remain with the lambda. So I'll remain with the lambda. The explanation, let me write x lambda. So this is as good as 1x, and then it is raised to the power 1. So 1 multiplied by 1 will be 1. And then we say 1 minus 1. Remember, as we are derivating, the power will reduce by 1. Okay, 1 minus 1 will be 0. So it will be x is 0 here, lambda. Anything raised to the power 0 is equal to 1. And then we have a 1 here, and then we have a lambda there. So 1 multiplied by 1 multiplied by lambda, it will just be lambda. Okay, I was just demonstrating. Yeah, but by now I should guess you're familiar with basic calculus rules. dl dy, I'm derivating with respect to y. Of course, there is y here, and y is raised to the power 1, meaning it will collapse. I'll remain with negative x. There is y here, 2 multiplied by 12 will be 24. And then 2 minus 1 will be 1. So remain 1 y raised to the power 1. But we just leave it as y. And then there is a y here. Since it's raised to the power 1, it will collapse. We won't remain with the lambda. Okay? Now, having done that, we can also derivate the Lagrangian function as with respect to lambda. Is there a lambda here? No. No lambda there. No lambda there. There's a lambda here. Okay, and the lambda is raised to the power 1, meaning the lambda will collapse because it will just become a 1. After it will be raised to the power 0. Here, the lambda will collapse, I'll remain with y. There, the lambda will collapse, I'll remain with 42. This is how we solve. Now, these two equations, I need to solve them simultaneously. I need to eliminate one variable. I can eliminate x, I can eliminate lambda. So I can eliminate any of the variables I will explain. So I'm getting just these two variables, or these two equations, 16x minus y let me push the lambda that side, or I can leave it here, plus lambda is equal to 0. And then I've got negative x plus 24 y plus lambda is equal to 0. Now what it is here is I can choose to eliminate x, I can choose to eliminate lambda, I can choose to eliminate y. If I want to eliminate x, I should multiply this equation by 16, so that I can have positive 16x and negative 16x here. So when I multiply by this by 16, I'll have a 16x here. I'll multiply everything, of course, by 16, but what I'm interested in is to eliminate the x there. So I'll have a negative 16x and a positive 16x, which will come and give me a 0. But I've observed that it's actually easy to eliminate the lambda, because here I just need to multiply by negative 1, so that this positive lambda becomes a negative lambda, so that I can have a positive lambda there and a negative lambda here. So now let me bring these equations here. Alright, so I have 16x there minus y plus lambda being equal to 0, and then negative 1 multiplied by x will be negative x. Wow, sorry, it was already a negative here. Yeah, sorry, beg your pardon, it was already a negative here. That is a negative x. Yes, negative x, so it's a negative. So negative 1 multiplied by negative x, that is 17. Sorry, that's a positive x. Negative 1 multiplied by x, positive x. Negative 1 multiplied by 24, negative 24 y. Negative 1 multiplied by positive lambda, negative lambda is equal to 0. So I have that. From here you can see that 16x plus 1x will be 17x, and then negative 1y plus negative 24y, this will be negative 25y, and then lambda, positive lambda plus negative lambda will be 0, so the lambda collapses. That's what I was trying to achieve. Then I have 17x here. Then this goes this side, it will be positive 25y. Alright? And then I can make x the subject of the formula, since here I'm trying to solve these simultaneously. So 17 this side, 17 the other side, I'll have x is equal to 25y over 17. So remember, I was dealing with these two equations. So these two equations, this is what they've given me. Alright? I didn't deal with that equation. Now I can deal with this equation by simply placing where there is x, I place 25y over 17. So where there is x here, I'll come and place I'll replace 25y over 17. So now I'm here in this equation. I'm saying x plus y negative 42. I can even just say equal to. Let me move the 42 the other side so it becomes a positive 42 here. Where there is x here, I can replace with 25y over 17, and then I have plus y is equal to 42. So I need to deal with this part. Okay, by making it a single fraction. So what I'll do is, this is as good as over 1 there. That's what we know. Any number, even 17, it's as good as 17 over 1 and something like that. Okay, so I have 25y over 17 plus y over 1, okay, is equal to 42. I'm making 17 the common denominator. 17 into 17, 1 multiplied by 25, so I have 25y here, plus 1 into 17 multiplied by the 1 in front of y there, that is 17y, is equal to 42. Again here we'll say that. Okay, now what I have here is that expression. With this expression, what can I do? With this expression, I can say 25 plus 17y, 25y plus 17y, I'm getting 42. So I have 42y here over 17 being equal to 42 over 1. I can cross multiply here. Okay, so I have 42, I'm just picking that. I have 42 y over 17 is equal to 42 over 1. I've just picked it the way it is there. So I'm cross multiplying now. 42y multiplied by 1, that will be 42y is equal to 42 multiplied by 17. So I'm doing now 42 multiplied by 17. I'm getting 714. So I have 42y is equal to 714. Alright. I'm dividing 42 this side, 42 the other side, so I can just remain with the y. That will be 714 divided by 42 is giving me 17. So y is equal to 17. Okay, so if y is equal to 17, I can still get the same expression here, which says x plus y is equal to 42. There's a negative here, I've just pushed the 42 the other side. So meaning where there is y here, I can put 17 for me to find my x. So I'll simply say where there is y, I'll put 17 is equal to 42. The 17 will go that side, I'll have x here is equal to 42. 17 when it goes that side, it will be negative 17. And then I have x is equal to 42 minus 17. That is 25. So x is equal to 25. Okay. So these are the units that should be produced to minimize the total cost that we have here. The total cost function is that. So this is the units that minimizes the total cost. Thank you.